So this is 3.11, number 15, related rates. And this one's hard because it's hard out of the question to see what they're really asking you. A spherical snowball melts at a rate. So you have a derivative. When a snowball's melting, what's changing? It's volume. So this is actually how fast the volume's changing because it's melting. Now, if things are proportional, what does that mean? Proportional means that if one doubles, then the other doubles. If the other triples, the other triples. If the other one's cut in half, the other's cut in half. So in an equation, if something's in proportion, basically they're equal to each other with a factor k making them different. So the surface area is 4 pi r squared. So this is the statement. The snowball melts at a rate, that's dV dt, proportional to its surface area. That means it equals its surface area times some constant of proportionality. Now, I would guess that most of you didn't know what a proportional relationship looks like. Now you know. They're equal to each other with a constant. So where do we go from here? Well, I see a dV dt, and you probably don't have to memorize this. They would tell you on an actual AP test. The volume of a cube is 4/3 pi r cubed. That's the volume. The next thing I want to tell you, the volume and the radius are all functions of time. As a snowball melts, the volume changes with time and the radius changes with time. So they're both functions of time. So I can take the derivative of this, realizing that v is a function and r is a function. Our variable is t, so those become box in our problem. Okay, we treat them as box. So what's the derivative of v if v is a function? Well, by definition, derivative of v is dv dt. 4/3 pi, those are constants. What's the derivative of box cubed? It's going to be 3 box squared times the derivative of box. But the derivative of box is just dr dt. Dun, dun, dun. These 3's cancel. And so here's our statement. 4 pi r squared dr dt. Well, this must be true because calculus. This must be true because they told us. So you look, those are the same. 4 pi r squared, 4 pi r squared. Our only conclusion is dr dt is our constant of proportionality. But they wanted us to prove that the rate of change of the radius is constant. We have proven that. Dr dt must be k, and k is a constant. So that's a crazy problem. I wouldn't expect many people at all to get that right. It's just one that's not easy. It's different. So yeah, if you didn't get it, don't feel bad. That's a weird one.